Okay, the next thing is a SQL injection attack, and SQL, or structured query language, is the language that actually is used to query databases and to put things into a database and also get information back out of a database. So by modifying the SQL query that's passed to a web application, when we visit a website, typically when we have a form, we want to do a search, we want to input some type of information, we're putting in our search term. On the back end, there is a SQL statement or a structured query language statement that is passed to the web server that then processes that data. Well, if you modify that SQL query that's passed to the web application, to the SQL server and so forth, it's possible to add code into that data stream and do such things as bypass a login screen or have that web server return information about the contents of the database, the various tables and so forth. So vulnerable websites can return usernames, passwords, account information, credit card information if it's not stored properly. It's typically supposed to be stored according to PCI standards in an encrypted format, but some websites may or may not actually store it in that fashion. And if they're vulnerable on top of that to a SQL injection type of an attack, it's possible to return that information back out of the database. And it can ultimately cause the application to throw, quote unquote, an error, basically meaning it's going to cause some type of unintended result, right? Because we're going to put in some information that the database designer did not intend. It's going to throw that error and either crash, or it's going to return some information that we as the attacker obviously would like to have, but the database designer or the application designer did not intend that information to actually become publicly available. Okay, the next is LDAP, or Lightweight Directory Access Protocol. And LDAP, whether it's in a Windows system or a Linux system, right, LDAP is used as an authentication mechanism. Right? It's an address book, quote unquote, of user accounts, and it's used to authenticate users. It identifies the level of access, group membership. So similar to SQL injection attacks, we can use an LDAP injection attack to basically pass a query to that web server and modify it in such a way that the database or the LDAP designer did not intend. In other words, we're going to inject malicious query statements or code into that directory, and again, have it return information that we're not supposed to have access to. Usernames, accounts, potentially passwords. So, as an example, we might have a form input on a website, and it's going to have a box. Okay, behind the scenes, the actual line would be input type text size 20, meaning we can put in 20 characters, and it's going to be our username. Okay, so we would input that username, and the underlying code might be an LDAP search. Right, it's going to basically take that common name, whatever it is we input, into the query, and then give us back some type of result. But if we modify that and ask for some information, instead of putting in just a username, we actually put in some SQL code or some LDAP code, well, then it's going to pass that additional query if it's not sanitized properly. And again, all of these types of injection attacks, the mitigation for this is to sanitize your input, meaning on the back end, the server needs to process that and sanitize, strip out any unintended information. So that way it gets cleaned out before it actually gets passed on to the database or to the server itself for processing. Similarly, we have an XML injection, and XML is an attack technique that manipulates the logic of an XML application or service. It can be used to inject XML, this type of query, into a statement that alters the path to a file or to disclose sensitive information. So as an example, all right, here we have an XML query, and it might say we want to return whatever. Okay, well, typically it's going to say, okay, the XML, this variable, is going to just return a piece of text or some type of information that the designer obviously intends. But if we modify that and we inject additional XML and say, hey, instead of returning the information that I'm supposed to get, if I do an XML injection attack, I'll turn around and put in where it says file, var www.config, or I'm sorry, www/config.ini, I'm actually pointing it to a file location instead of just some harmless piece of information, right? Some intended result. So by giving it the malicious code, I'm actually going to have it return the result, which is the file, the config.ini in this case, which gives me basically all the parameters and all the configuration information for that specific website. Again, by sanitizing input to making sure that we're not allowed to enter things that are over and above what's intended, we can mitigate a lot of these attacks before they get a chance to get processed by the server. And also, just to make sure that we're clear, there are ways that we can test against these types of things, something referred to as fuzzing. And in fuzzing, we can use it either as a white hat hacker or a black hat hacker, right? We can use it for good or evil, right? And the actual application designers themselves can use this tool set to test their applications. So it can find bugs and defects and security holes in applications, because by fuzzing, we can pass large amounts of information into these input forms, random characters, wildcards, non-alphanumeric characters, and just over and over and over again, try tons and tons of different variations and iterations to find some that potentially are mishandled by the application. In other words, we can keep passing it stuff until it breaks. Or we can validate that it's not going to break because it's being sanitized properly. So by fuzzing, we can use it to make sure our applications work the way they're supposed to. And we can also use them, if we're on the other side of the coin, maybe a black hat hacker, we can use fuzzing techniques to identify zero-day vulnerabilities. And as we've learned, a 0-day basically means a bug or a vulnerability that has no patch yet. Okay, we'll cover that in just a moment. But it's referring to something that's found and exploitable that the actual developer has not had a chance to fix yet. So at the end of the day, it's used to crash applications, websites, and so forth. All right, so that leads me to the mitigation that I alluded to just a moment ago, and that is secure coding. All right, we want to do input validation. We want to make sure that we validate and sanitize. And when I say sanitize, I mean we're stripping out characters that aren't supposed to be there. We're pulling out all the garbage, basically. All right, we're sanitizing what's entered at the client side or the server side. It can be either, depending upon which type of validation we do, client side or server side. But in either case, we're going to validate and sanitize that information before it's processed, right, by the server. So that would mitigate attacks such as cross-site scripting and SQL injection attacks. And here are just a few examples of some tools and so forth that we can use for input validation and to make sure that our applications are behaving the way that they should.